Hello class, in this experimental lecture we'll be looking at synthesis of diphenyl ketone. Also you can call it by its IUPAC name 1,3 diphenyl propane 2-on. And this specifically this experiment is based on a journal paper published in 1962. You can go ahead and look the journal to get more detailed information about some specific experiments we'll be discussing. Take your time here to just recall the molecular formula of phenylacetic acid or phenylethanoic acid, and also try to remember the formula weight of this acid and iron, as well as our product, the diphenyl ketone. And the reaction below is what we will be doing in this experiment. So what do you think our yield will be for this experiment? If you had a chance to see the paper ahead of the lecture. So we're going to do the experiment in two sections, and each section have 18 students, where in each section there will be a group of students with maximum 1 to 2 students per group. So from the experiment for synthesis of tetraphenyl cyclopentadienone, the experimental procedure says we need about 1.05 gram of diphenyl ketone. However, in this experiment, we just for experimental purpose, because we are doing the experiment for qualitative purposes, we'll be using half of this amount. So if we're going to use half of this amount per group, and if we have two sections overall to do this experiment at the same time, and if each section has 18 students, where 2 students will be grouped in one group, how much gram will we need to do the experiment overall? I mean the total grams we need for both of the sections, or for every student in a group. So how much diphenyl ketone do you think also we need to try to synthesize? Now, the research we use as a reference for this experiment says that their yield was 71%. And what are we going to do with this percent? I mean, just to give you a clue, whenever a yield is reported, it can be either just the experimental yield, what they got from what they use, or as we do in organic chemistry labs, the yield is calculated or reported as percentage yield. And as you know, the percentage yield is a product of when an actual yield is divided by the theoretical yield. The actual yield is the yield we get from the experiment, and the theoretical yield is the yield we can calculate from the reaction. So if we have this yield, what do you think we should do with that? And remember that we take this yield from the experimental, from the actual research. Well, to give you a brainstorm so that it helps you to give it a deep thought on how to figure out how much of the reactants we need to produce the amount of yield we need, take this financial brainstorming statement. Let's say you want to live in a neighborhood that costs $1,000 per month, and if you follow the standard budget recommendation for living expenses, and as they say, you have to spend 25% of your income for housing. How much do you think you should earn per month to cover 25% of the $1,000 which you will be paying for the housing? And yeah, give it a thought, and that may help you to answer the previous question. So how much of phenylacetic acid and how much of iron do we need in this experiment? So taking the yield into the consideration, what grams of the dibenzyl ketone, the product, are there in 71? What grams of these products constitute 71% of the overall yield? And remember also from the reaction that 1 mole of the acid reacts with 1 mole of the iron. 2 moles of the acid reacts with 1 mole of the iron to produce 1 mole of the product, the diphenyl ketone. And in such a way you can calculate the yield. Also for iron, we can calculate it by looking at the reaction, what product or how much gram of the product is 71%. If 1 mole of iron, which is 55.85 gram, produces 1 mole of dibenzyl ketone, which 1 mole of the compound is 210.28 gram. And here you can see 1.1 added into the calculation because iron is very susceptible for oxidation. That's why the researchers recommended an excess use of the iron in the reaction. So to do the experiment, two groups can weigh the acid. One of the group can weigh the acid and the other can weigh the iron, whereas the other third group can weigh the final product. In that way they can share to the class. So we're going to do this experiment in a 3-necked round bottom flask, and we'll start that by adding phenylacetic acid into 3-necked round bottom flask, and then we can increase the voltage to 50%. And because this experiment will be done in a fume hood and we're using an organic reactant, we need to lower the slash of the hood so that we can protect our service. In the reaction, you'll be monitoring also the byproducts, especially the gases, carbon dioxide and hydrogen, that will be coming out. This is the picture for the experiment we'll be doing, and the first one is the round bottom flask connected with thermometers. The middle flasks are just flasks to slow down the gases so that we will be able to combust them. Well, how do we, so with the gases we will be obtaining here, the only way to trap or absorb them is using water. What you can use is what you can do is you can take 100 ml of graduated cylinder, fill it with water, and then close it um, with your hand, and then you can invert it and submerge it into the water, where the hose will enter, and you can place the mouth of the cylinder near to the hose so that it will be able to suck the air, the hydrogen or carbon dioxide that comes from the experiment. If you like, you can do this monitoring turn by turn, because I'm interested, some students may be interested to see what's really going on, but please do not use gloves here, because we're absorbing hydrogen and we have an oxygen in the air, and the whole setup is under heat, and you can imagine what will happen. And in the process, the hydrogen production will stop, and the carbon dioxide will start to bubble or to come out, and that is a confirmation for the second step of the reaction. And how much water do we need to displace? Because the amount of the water we displace is proportional to the volume of the gas that we're absorbing. So normally it's estimated that around 1/3 of the displaced water will be hydrogen, because of the atmospheric proportion of the gases. As you know, only 20% of the atmospheric gas is oxygen, whereas the larger percent, 78%, is hydrogen. Sorry, nitrogen. And because you are doing this underwater, you get 100 ml. You use it 100 ml, say, graduated cylinder, means just 1/3 of that amount is hydrogen. The other 2/3 are going to be oxygen, due to the fact that in the ratio of oxygen and hydrogen in water is 1:2 ratio. If you're interested more, you can precisely go for the estimation for the actual estimation of the yield here, or for how much gas you will be able to absorb. How much hydrogen will be producing then? So you have the volume from the displaced amount of water, and because gas and liquids should be reported in terms of volume, and as a standard as a standard temperature and pressure, 1 mole of an ideal gas has 22.4 liters. But to calculate that, what do you think here? Do we need to calculate the volume of the hydrogen produced in terms of the acid, or in terms of the iron? Imagine the physical properties of the acid and the iron, and you can guess which of these chemicals will be used, or reactants will be used to estimate the amount of hydrogen produced. One good information here is to show you how hydrogen is produced in the mechanism. So it's a general property that when metals react with acid, they produce hydrogen gas, right? And here, when the metal reacts with an acid, uh, in fact, because we're using so the mechanism, in the actual mechanism, just we have an acid and metal reacting, but you'll be able to see how that is apt to be. So when the metal reacts with hydrogen bond, what it does, it homolytically break the bond between hydrogen and oxygen, which means hydrogen radicals will be formed. The alkoxide radical will combine with the metal to form salt, whereas the hydrogen radical is very reactive and it traps another hydrogen radical and gives the hydrogen. In the same way, when the metal, for instance, in our reaction for this experiment, iron will react with the acid. In similar way, it traps the hydrogen atom, then the acetate radical will be formed, and two of the acetate radicals will stabilize by sharing their electron with iron, and as a result, hydrogen gas will be produced. So when this intermediate that we got from a reaction of the metal with acid, if you react it with a Lewis acid or base, or preferably heat, what it does is the Lewis acid facilitates a tautomerization, where you can see at the right in part of this structure becomes an enol. It's a keto group first, and from the methylene group between the phenyl and the ketone, one hydrogen will be displaced and attached to the oxygen carbonyl carbon, and as a result, a double bond will be formed between that carbonyl carbon and the methylene group, which means the keto group have converted to enol. And this enol will then make a Claisen rearrangement, intramolecular Claisen rearrangement, to give us the final products and the byproducts. You saw how we found hydrogen there, and here is the full reaction with the second step, including carbon dioxide, which will be formed after the hydrogen has evolved, or after production of the hydrogen has finished, because hydrogen forms in the first reaction of the metal with the acid. Alternatively, you can also synthesize the product by condensing the acid. What you can do is, to condense the acid, you need to, because two acids will not react anyway, and you need to make one of the acids into a nucleophile. So when you react the acid with alcohol, you will have an ester. And if you react one of the moles of the ester with a base, methoxide, use it here, and what it does is the base will abstract one hydrogen atom, and you will create a negative charge. Because we have a carbonyl carbon, the negative charge can undergo delocalization, and then when this pair of electrons, the newly pair of electrons, are used to attack the carbonyl carbon in the 1 mole ester. Imagine that we're doing a condensation reaction, which means we have to condense 2 the same kinds of compounds. Here we're using the two acids together. We first converted one of the acids into ester and again into a nucleophile, and then the second row is the reaction of the nucleophile form of the ester with the other mole of ester. So now we will have another intermediate formed from these two fragments, and then when you hydrolyze this ketoester complex compound, what happens is the ester, the methoxy part of the ester, will become an acid. And if you heat the acid, what happens is it undergoes intermolecular rearrangement again, and then we will have the final product. Here the R groups are just to generalize the reaction, but you can imagine them as if they are phenyl groups, and we have a carbon dioxide, which will be the final step for the reaction. In the end, we get a diphenyl ketone. So some checkpoints here. Try to figure out the pattern of this overall reaction, and which mechanism do you think is addition reaction, which one is elimination reaction, or which part in the mechanism was substitution reaction. And in the general reaction shown below, what elements are oxidized and what elements are reduced. We used an iron metal, and we have also generated carbon dioxide, hydrogen, and iron oxide from that. And if you can analyze the oxidation states of the products, you'll be able to understand which of the elements are oxidized or which of them are reduced. So after the first reaction of the acid with a metal, we say that the hydrogen will stop because the hydrogen is formed normally between the radical of the acid and another hydrogen normally from the environment. So how do you think we know that the hydrogen stops? Remember that you're using the water displacement to trap hydrogen. So with that, how do you think you'll be able to know that hydrogen is no more produced? And again, to go with the second step, you will need to increase the transformer from 50 to 100% voltage at 1% per minute increase, and then you'll see the carbon dioxide coming out. Again, trying to notice what makes you what's the confirmation evidence to say that the carbon dioxide is evolving. And once you reach the 100% voltage, you can cover the round bottom flask by aluminum foil to initiate a heat transfer, but please do not touch the surface of the round bottom flask with the foil, as it will abrupt the heat increase in the flask. Then in the process, after you cover it with aluminum, you will see the benzyl ketone distilling, and record the temperature at which the thermometer tells you when this distilling is is going on. And do you think that benzyl ketone is liquid or solid? So you can imagine this before you do the experiment, because when you do the experiment you'll be able to see what the benzyl ketone looks like, and from that it might not be difficult to tell what it is. Anyway, do that as a part of this experimental, as a part of requirement for this experiment. And once the benzyl ketone is distilled, you'll see a temperature drop in the thermometer touching the liquid, whereas the outside temperature still be increasing, and that means it may lead us, I mean, it may warm the thermometer, and we may lose our thermometer. And to prevent that, we need to lower the heating, and then we need also to remove the hose from the water, because the water will not suck back and contaminate our sample. And finally, you will need to measure the weight of the product. And for the setup, after the experiment is done, the TA will manage it to cool for some time, and he will then also wash all the necessary equipments used here with acetone and with hydrochloric acid. Normally we use acetone to remove any of the organic residues, whereas we use the acid to remove any metal residues. And then you can add the TA in disassembling the apparatus actually during the experiment. Finally, the products will be analyzed by using this most commonly used strong spectroscopic techniques, IR and NMR, and the results will be shared to you on module, and you'll be able to see if you have synthesized the correct product or not.